Here we go. We're going to recap what we did yesterday. Multiplying matrices is the key. So, yesterday you learned how to add matrices, subtract matrices, and the hardest one was multiplying matrices. Not multiplying by a scalar. Multiplying by a scalar was pretty easy. It's multiplying by the matrices, and I showed you there were two rules that you had to check. Okay, and then following with the row 1, row 1, column 2, that's the technique, yeah? So, let's go through a recap. We're going to go through dimensions of matrix A. So matrix A, what's my dimensions? Can I please have Hamish? It's a 2 by 1, 2 rows. You can see there's 2 rows here. You've got row 1, row 2 there. So, whoops. This is a 2 by 1. Okay, and then you look at the next one. 3 and 4. So matrix B, what is my dimensions, Will? 1. Good, 1 by 2. Okay. Now, we're going to try to find matrix A times matrix B. So it's in this particular order. A comes first before B. Now, in order for that to work, we're going to look at it as this is a 2 by 1 multiplied to a 1 by 2. So you question yourself and you say, rule number 1, what must work in order for you to multiply? Rule number 1, does this one work? And? The row of the second matrix. So you can see the column is 1 here, and it has to match with the row of the second matrix. The second matrix is 1. So these two match. Okay, if those two match, then we're good. These two work. So rule number 1 works. It tells you that you can multiply them. Rule number 2 tells you the ending result. Now, how do you know what the ending result or the size of the result matrix? What was rule number 2? Yasmin? Good, the 2 end values. So that's a 2, and that's a 2. So the 2 end values will tell you what the ending matrix should look like. It's a 2 by 2. Okay, so the ending result will be a 2 by 2. That's rule number 2. Okay, so rule number 1, you have to check if these two are the same. If they are the same, it means you can multiply them. If you multiply them, then that will be your ending matrix. Now you know it's a 2 by 2. You know your matrix, when you multiply 5, 1, by 3, 4, you know the ending matrix needs to be row 1, row 2, column 1, column 2. You know you have to have a 2 by 2. So how do you work them out? Row 1, so if you want this entry here, that entry there will be row 1, column 1. So you multiply row 1, which is a 5, times by column 1, which is a 3. And in our case here, we only got these two as our first numbers, so it'll just be 5 times 3, which is 15. So I know row 1, column 1 has entry 15. I do row 1, column 2, so row 1 has only a 5. Column 2 has a 4. So 5 times a 4, 20. Okay, and you fill out the others. That becomes now 3 and 4. Okay, so row 2 times column 1, row 2 times column 2. 3, 4. Okay, does that make sense? That's just recapping yesterday's multiplying A to B. Now, what I didn't mention yesterday, okay, so what I didn't mention yesterday, which I'm going to try to remove these ink, is what if we did B times A? Okay, so let's try B times A. Now, in order to do B times A, now you have to look at the dimensions of B. We said it was 1 by 2 multiplied to A, which is a 2 by 1. Rule number 1, check if they work. Yes, they do. Column of the first fits with the row of the second. So yes, that works. But what's my ending matrix right now? It's a 1 by 1. Okay, so if you look at it, it's a 1 at the end and a 1 at the end. So it's a 1 by 1. So that's already different. That means A times B, matrix A times B, gave you a 2 by 2. But when you switch it around, if you do a B times A, it actually doesn't end up being a 2 by 2. It ends up being a 1 by 1. That's already different. And the reason why is because you're using matrix system and not a number system. You're used to number systems where A times B equals B times A. It's like 2 times 3 and 3 times 2 are the same, but not with matrices. Okay, and that's the one thing. That's why we don't have division. That's why division doesn't work. And I'll show you why on the side so you can see the clarity to it. But let's try to work this out. So we know it has to be a 1 by 2 times 2 by 1. It has to end up being a row 1 and a column 1. It's a 1 by 1 matrix. So we follow this. Same thing. We know it has to be a 1 by 1 matrix. Means that it has only row 1, column 1. So row 1, I've got 3 and 4. Column 1, I've got 5 and 1. Now when you multiply them, remember it's the first of each one, you correspond them together. So it's a 3 with a 5, so you pair the 3 with the 5. It's the first of the first row with the first column, second of the row with the second of the column. So that's why you do 3 times 5 plus 4 times 1, and that's how I got the next line. 3 times 5 plus 4 times 1, that now gives me 19, which is a 1 by 1 matrix. Okay? Now, the only thing I wanted to mention in this slide here was for you to understand, it's not like your algebra system or your number system, A times B is the same thing as AB times A. Okay, because those are numbers. 2 times 3 and 3 times 2 are the same, even if you switch it. But for matrices, it will not be the same. AB does not equal to BA. And this is why division doesn't work. You see, with division, with the algebra back then, you could say divide both sides by A divided by A cancels out to be 1, and B equals B. So that's true. But you can't do this, because if you now divide this by A and divide this by A, no, because AB did not equal to BA. We already proved it here. We already showed that BA equals 19, AB equals to this 2 by 2 matrix. So here, you're actually saying B does not equal to B. How does that make sense? Okay, which, you know, it makes B is meant to be the same. 3, 4, and 3, 4. Those are 2 of the same B's. But if I do it algebraically here, it doesn't make sense. That's why matrices does not have division. Okay, and because it doesn't have division, that's why this exercise today is going to try to figure out, well, we always use division to go backwards. So if I can times by 2, I can divide by 2 to move back. The problem is if you can times by a matrix, but you can't divide by a matrix, how do you move back then? And so we had to work out an inverse, and that's what today's exercise is about. It's about figuring out an inverse to it. Okay, and luckily for you, we already figured out all the proof and formulas for it. You just have to remember the formula. Normally in year 12 I teach the reason how the inverses work and the proof for it. But given our short time, it's only one exercise as well. I'm just going to give you the formula, show you how to do it, and you practice that. Okay? So here we go. Matrix inverses. So our problem were the inverses. Yeah, we're up to 7F. Because we did A, B, C, D transformations last term. And you guys did really well on that one. E was yesterday. Okay, so add, subtract, multiply matrices. Now we're trying to work out, well, if we don't have division, how do we reverse multiplying a matrix? Okay, so this is what we figured out yesterday. We did add, subtract, multiply, but you can't divide. Okay, so I showed you just now we cannot divide. I gave, I'm making up these matrices here, so copy these 2 matrices down. Okay, this is what we can do so far. Yesterday, if we had x plus a equals b, since we can add a matrix A, then we can also subtract a matrix A. So what you said yesterday, well, when you're solving for exercise 7E, you could say subtract matrix A on both sides. A minus A will cancel out. Yes, you can do that. We can add, we can subtract. So we can find out x because it's just matrix B minus matrix A. That will tell me matrix X. That's what we did yesterday, right? We could also do it if it was multiplied by a scalar value, meaning that if I had matrix X and then times by 2, I can get rid of it. Why? Because I can divide both sides by 2 now, but why can I do B divided by 2? Didn't I just say we can't divide? I said we can't divide, but why can I do this? It's scalar. Not only that, another way of looking at it is B over 2 is the same thing as saying half times B. Yeah, B divided by 2 or half times B is the same thing. So it just means whatever B is, I'm going to times all the values by half. Okay, so we can do that. So scalar we can. What was the issue yesterday was when we do this. Now if you have matrix A, which is this a 2 by 2, multiplied to a matrix X, which I don't know, equals to B, my problem is, yes, and in those specialists, that's where you learn the inverse, and that's what we're doing today. We can't do this one. We can't do 1 over A, because that actually ends up being 1 over this matrix times B. How do we do that? We haven't learned that. There's no way we can do that. None of our techniques from 7E has allowed us to do that. This is an issue here. So all of this worked. This worked. That worked. This was an issue. Okay? We didn't know how to solve that problem. That's what today is all about. It's all about how do I reverse that A multiplied to that X matrix X, how do I remove the A so that I can find out X? So my goal is to figure out X, okay? And in year 12, you understand what X actually represents. But at this point, I'm just going to leave it there. Okay, normally it's just transformations, it's two linear equations, but you're just going to learn how to find out X, okay? So, here we go. This is our problem. AX equals B. Now the only things we've got is add, subtract, multiply. We don't have to divide. So what we're going to do is, they came up with an idea. They said, all right, well, there's no point adding because it's currently being multiplied. The only way is if I can somehow multiply A, or on this side, if I can multiply this matrix by another matrix, multiply, because I can't divide, what if I multiply by something to get rid of A? It's kind of like saying, what if I had 2x, right? What if I decided to times by half? See, if I times by half, half times 2 will cancel out to be 1. 1 times x ends up being x equals 2. Half times 4, which is 2. Yeah? We can do that. We can do that because we're multiplying. I'm not dividing. I'm using, the only method I have here is multiplying. So the goal is they're saying, what if I multiplied this matrix, which is what Ian just said before. He said multiply by the inverse. But we don't know what the inverse is. We're just saying, make up a matrix. What if we had a matrix that I can multiply to A such that these two will cancel out just like half times 2 will cancel out to be 1. Because 2 times half is 1. It cancels out because 1 times x is x. What if I can figure out a way where two matrices multiply to each other and it comes out to be not 1, but we call it an identity matrix, which is the new term that you're going to learn. Something times x will give x. That's what we want. This is what we want. We want this step here to be true. We want something times x will end up still being x. Okay? This is the goal. So this is the map of what we want. Okay? Problem is there's a few things we don't know. Is it even possible to get a matrix where it acts like a 1? Is it even possible to multiply something to A to cancel it out to become 1? Okay, that's the goal. So there's 2 steps there that you need to look at. Yep. I just put the -1 to call it the inverse, because when we're writing notations inverse, we normally put a -1. Yeah, that's all. It's just a notation. I could have called it C if it makes it easier. I could have called it matrix C. So I just want another matrix multiplied to A such that these two will cancel out and I get something equivalent to 1. Kind of like what you did over here. Half times 2 will cancel out to be 1. And why do I want 1? Because 1 times the x ends up being x. And my goal is to find x. Okay? Could you put 1 over x? No. We want x. We don't want over x. Yes, but it's not what we want. We want x. We only want x. We don't want 1 over x. Okay, so just keeping in mind, this is what we want. We want to get something, a matrix that it could be equivalent to 1. So then when I get this matrix times x, I just get x. That's the goal. Okay, now you don't have to figure out this matrix here because they've already figured it out for you. They figured out that actually, if you multiply by this kind of matrix, if it's a 2 by 2, if you've got a 2 by 2 and you multiply by this 2 by 2, this will always give the same matrix. It acts like a 1. So they end up calling this, they gave it a name, they call it identity matrix. So you don't have to figure it out, they already told you. Okay, they said, all right, this was a problem, but they figured it out. They said, if you multiply this X matrix by 1, 0, 0, 1 in that kind of pattern, you will get itself. So if you had a 3 by 3, then the identity matrix would end up being a 1, 1, 1, 0, 0, 0, 0, 0, 0, 0. That will end up being its same. It will be like a 1. Okay, that's what they figured out. So, because our case, we're only working with 2 by 2 matrices, you're going to learn that the identity matrix, which they use the letter I, is 1, 0, 0, 1. Okay, yep. Absolutely. Yeah, and that's what they figured out. And I'll show you what happens when you multiply by I, which is that kind of matrix, and why it does equal itself. So let's take an example. I said B was 8642. Yep? Now if I asked you to multiply BI, this is what I'm asking you to do. I want you to take B multiplied to the identity matrix. Apparently, BI should actually give you B. That's what it should be. Okay, that's what it should end up being. So let's try that. Let's check this one out. This is a 2 by 2, multiplied to a 2 by 2, so that works. Okay, 2 by 2 by 2 by 2. So 2 by 2, 2 by 2. Rule number 1, it works. Rule number 2, it ends up being a 2 by 2 matrix. If I multiply them, row 1 and column 1. So 8 with a 1 plus 6 with a 0. So that's what I've done here. 8 with a 1 plus 6 with a 0. Row 1, column 2. So row 1, column 2, 8 with a 0, 6 with a 1. Now if we follow that pattern, what you'll see is those zeros are nice because 6 times 0 will cancel out, 2 times 0 will cancel out, 8 times 0 will cancel out, 4 times 0 will cancel out, and what you end up with, 8642, which is exactly the same as B. B is the same. And that's what we wanted. We wanted something times x, and it doesn't change x. X is still the same. So B times I still is B. And that's beautiful. Okay, so that means we can now figure it out. We can say, I want this to be this. Yes, ma'am.
Why do we actually use I?
Because without this, because remember, our goal is to remove the A, right? But you can't just take it away. We can't just like rub it off. There has to be something.
But I know, right?
Yeah, I know, but I'm teaching the why it works. So the inverse of A will cancel out. But when you say the word cancel, see, a lot of people think it just magically disappears. It doesn't. When you say cancels, it has to become something, because half times 2 doesn't just disappear. Half times 2 becomes 1. But 1 times anything is itself. So this is what we want. We want A inverse times A to cancel out. But when we say cancel out, what we really want is it becomes a value or something, and when you multiply to x, it doesn't change. X.
Okay.
Yeah. And so that's why we needed something. Now that something, they figured out for you. They figured out that something has to be a 1001.
Okay.
And so now that we know that A inverse times A, we need it to be equivalent to a 1. And what we figured out is, or what they figured out is, this has to be 1001. And that's where the proof comes from, actually. But I won't show you the proof. They now figured out, they said, your goal is to now just find A inverse. Because if you know, listening, if you know A inverse, you can get I. If you can get I, you can get X. And then you're done. So your job now is just to find A inverse, which is the color-coded red. That's what you want. Thankfully for you, they figured it out for you already. That's the rule. Copy that down. Okay? So that's the theory. That's eventually your goal is to solve for X. The problem was you couldn't get rid of A, but now they can. They figured out I for you, and they figured out A inverse for you. Okay? There is proof for all of that. And this is the rule. You're going to have to memorize this rule for the matrices. It's 1 over A times B minus BC. What's AD and BC? That's your matrix, a 2 by 2 matrix. A, B are the first two terms in the row, first row, and C and D, second row. Okay, so A, B, C, D.
Okay, so I forgot for the inverse, right? Like, is it the O1 or U1? The AD minus BC is the O1 or U1? Other switch side or before switch?
What do you mean by O and U?
Like inverse, right? Both sides and then minus.
Yeah.
Yeah, but but like which one? AD minus BC, which one? The O1 or
This is O1.
I know, but like should I multiply the AD by O1 or U1? The AD.
AD is this one. Yeah. I'll show you. All right. As you're copying that formula down, I'll show you the example. So remember I told you to copy that matrix A was 5, 2, 2, 1. Okay? and I said I wanted you to solve for x. The problem was you didn't have a way to divide. We figured out, or they figured out, there's a rule to find the inverse. The inverse just basically tells you can cancel out a to become I times x would just be x. That's what we know. Okay? Now A inverse, we've got the rule. Now if you look at this matrix here, what is my A, B, C, and D? Look in that matrix there. So if matrix A is 5, 2, 2, 1, then according to this, what is my A, B, C, and D?
5, 1.
Yeah. A has to be 5. This is my A. 5, B, C, and D. So now if I use my rule, you'll say the rule is 1 over A times D minus B times C. So let's work that out. A, which is my 5, times D, which is 1, so I wrote 5 times 1, minus B times C, so B is 2 and C is 2, so 2 times 2. 5 take away 4 is 1. Now, be careful. Remember, this is being switched. D and A are switched positions. So that means 5 and 1 will switch position. That's why I've got a 1 and a 5 there. That says negative B, that says negative C. That's negative 2, that's negative 2. Okay? And because this ended up being 1, I can ignore that 1 times all these terms gave me this matrix. And this is nice. Now that you've got a way, remember matrices you don't have divide. You only had add, subtract, and multiply. That means now to solve for x, I can do it. I can say multiply both sides by A inverse, and I will be able to get x, because these two will cancel out. These two will cancel out, and you will get x equals to A inverse times B. Okay, and now you know A inverse, and you know B from the previous slide. You can do matrix multiplication to solve. Okay. Yes. Yes, that's where I was going to get to as well. So, with your at your current level, year 11 and 12, you do not need to learn how to do a 3 by 3. Okay, you'll learn in year 12 how to do it on a calculator, but you don't need to know how to do a 3 by 3. Your job only is to do a 2 by 2. Okay, when you get to university, you start to learn 3 by 3, and then you'll be able to do 4 by 4s, 5 by 5s, 6 by 6. It just gets tedious to do, but you'll learn how to do it. That's the first year uni, first semester, first subject of mathematics. You'll be learning how to do matrices, 3 by 3, 4 by 4s. Yeah? But in year 11 and 12, you only learn 2 by 2s, and that's the only formula you get for 2 by 2. Okay? So with the 2 by 2, that's the rule. Make sure to copy that down. And the theory I try to give to you is here. We couldn't do that before because we didn't have divide, but we can times. We figured out that times by an inverse, another matrix, to get identity matrix to get x. Okay, so now it's possible. All right. Now, one thing just to be careful of that I see mistakes in the exam, and write it down as your notes, is when you multiply by the inverse, it does matter where you put the inverse. If you wrote A inverse on the left-hand side to get rid of the A, then you have to write it on the left-hand side of B. Okay, you can't do this. You can't just say, all right, how about I do A inverse on the left and then do A inverse on the right. Don't do that. Because we knew B times A and A times B are different. You can't say A inverse times A, which is A inverse is on the left. You can't then just say A inverse is on the right here. Okay, that wouldn't work. So if you times it on the left to get rid of the A here, then you have to times on the left. What you can't do as well is to decide, well, what if I times A inverse like this on the right-hand side? Will that work? No. These two do not cancel out. They have to be right next to each other. They have to multiply to one another. Okay? So if the A is on the left, you have to multiply inverse on the left. If the A is on the right, then you multiply the inverse on the right. Okay? What I'm trying to say is, if you get a problem where you get XA equals to B and you're trying to solve for A, then you will be multiplying A inverse on the right, and that means you have to multiply A inverse on the right as well. Okay? So A inverse and A have to be next to each other. That's how you can say that cancels out. Then that has to be on the right-hand side. Okay? So the position does matter with matrices. That's why I did the first slide. Okay? So AB, BA don't equal the same. Okay? But that's it, that's the theory. Okay, so make sure to copy the notes down. I wanted you to have A inverse as your formula. I wanted you to understand what an identity matrix is. And there's one last thing. If you're looking at this formula, which I want you to study it, or just have a look at it, it can be undefined. Oh, and when will it be undefined? Someone see. Oh. When will it be, not when it's negative. Oh. When will it be undefined? Why? How is it possible in this formula here where it becomes undefined? Yes, ma'am.
Oh, 1 with 0.
Yeah. What's determinant though? Yeah. So without even knowing the word determinant, that's the name for it. So if you haven't learned special, you know from rectangular hyperbolas, you can't divide by 0. So if A times D minus B times C ends up being a 0, you can't do 1 divided by 0. It's undefined. Now I want you to think a bit. What does it mean if it's undefined? What happens when A inverse is undefined?
No solutions.
Yeah, you can't figure it out. Because your goal before was to solve X. If you can't find inverse, then you can't solve for X. If you can't do this first step, you will get an A inverse. So what I want you to copy down as your last notes, in Spec, they call that the determinant. That will determine whether you get an answer or you don't. AD minus BC, if it equals to 0, that's a problem. Because 1 divided by 0 is undefined.
So, like ones with like 0.
So AD, so
like
this one's
A
here.
and B equals 0. Then
Now AD minus BC, if this whole entire thing ends up being a 0,
undefined.
It's undefined.
A and B equals 0, then it would be 0.
so for example, if I change that 5 to a 4, if I change that 5 to a 4, that would end up being a 0. That'll be undefined. But if this was a 4,
Okay.
yeah, okay, that would end up being 0. So that right there, A times D minus B times C, if it equals to 0, it's undefined. But if it's undefined, then there is no way you can solve for X. Okay? Later in year 12, that X will represent something. Okay? That will mean something to you. And it will remind you of the things I taught you in the very first chapter of this year, where I talked about infinite solutions, one solution, and then no solutions. Yeah? So unique solution, no solutions, infinite solutions. This is what you're doing next year. That's what you're solving for. Okay? Parallel lines, infinite lines, and unique lines. Okay? But anyways, those are the two formulas you got. Determinants, which another way of writing it, they sometimes call it like this. Det A. Det A is just short for determinant of A. Okay, so if you want to find det A, it's whatever A times D is minus B times C.
Why is it not det A negative? I'm just trying to figure out inverse A.
Yes, you are, but the A, B, C, and D come from A. So the determinant of A. Yeah. So the A, D, B, C are from the A value, and this tells you the inverse. Okay? Here we go. Let's try to do one example. Copy this example down. You got A equals 3, 2, 1, 6. Let's find determinant. What's the rule for the determinant again? AD minus BC. So here we go. Determinant of A. It's AD minus BC. What's my A, B, C, and D? Can I please have Olympia? What's my A, B, C, and D?
3 times 6 minus 1 times 2.
Good. Okay, so B is my 2, C is my 1, and A, which is my 3, times 6. So write it down. 3 times 6 minus 2 times 1. 18 minus 2 is 16. So you found determinant of A. What's the rule for the inverse again?
1 equals inverse.
A inverse is equal to what, Felix?
1
Yep.
over AD minus BC, and then a 2 by 2 matrix, and D.
Yep.
And then below that is negative C.
Yep.
And then it's negative B.
Yep. Good. That's your rule. You've got A, B, C, and D. You've just figured out the determinant, which is AD minus BC is 1 over 16. So if I apply it using the rule, is what I should get so far. 1 over 16. My D, which is 6. A, which is 3. B is a negative, so negative B, negative C. That's my A inverse. Now your goal in part C is to find X. you've got A times X, matrix A times X equals to 5, 7, which is what I have over here. What's the issue? You don't have divide. You want to get rid of matrix A. We don't know, we can't divide. We can add, subtract, and multiply, but I need to get rid of that A. Or we can inverse. We can multiply by an inverse. Now remember, the A is on the left, so where do I multiply the inverse? In front, so which is on the left as well. Okay, so I'm going to multiply A inverse on both sides. Now I know that through the theory, these two should cancel out to give you I, and I times X should just give you X. Okay? So remember, if I multiply A inverse on the left, I'm multiplying A inverse on the left of 5, 7. A inverse, I already found out, it's this one. Okay? We figured out A inverse already, so I just need to replace A inverse in red, and I color-coded for you here. A inverse is just 1 on 16, 6, 3, negative 2, negative 1. Now you use what you learnt last session. Multiply the matrices, row 1 by column 1. Okay, now let's think about it. This is a 2 by 2, and this is a 2 by 1. So what's my ending result?
2, 1.
2, 1. Rule number 1, they both work. Rule number 2 ends up being 2 rows, 1 column. 2 rows, 1 column. Here we go. Row 1, column 1. So row 1 times column 1. 6 times the 5 plus negative 2 times the 7. That's what I write here. Row 2, column 1. Negative 1 times the 5. 3 times the 7. Add them together, and you should get 16, 16. But remember, we don't like to write, you can sometimes leave it like this, but 1 and 16 on the outside, remember, it's a number. You can times 1 and 16 to the 16, and 1 and 16 to the 16. That's from yesterday's lesson, times it by a scalar. Okay? Now 16 times 1/16 gives you? 1. Okay. There you go. So now you can find out x. Okay? That's pretty much all you're doing for this exercise. So the hardest part of this exercise was really just the multiplication. And that's what I meant by yesterday. The hardest part is learning matrix multiplication. Inverse is pretty easy. Use the rule. There's only 2 rules there. Solving. Your goal is to multiply. But that's it. That's it for today's session. And that's exercise 7E, 7F. Okay, combine those 2 together. That's most of your specialist matrix methods. Okay, so if you've done specialist, you would have done this already with more exercises in it.
So let's say,
Wait, let me stop the video.